So for problem number 1, we have to convert this into a system of first order linear equations. So let's write this down. Okay, so we are given this equation with some first order equations. Y of 0 is equal to 1, y prime of 0 is equal to 2. Let's start, guys. So we are given this information. So these are pretty simple problems. They don't really ask you to solve them further except find the first order equations. So we set x1 equal to y, x2 is going to be x prime of x1, so this is equal to y prime. x3 is x2 prime, so it's equal to y double prime. x4 is equal to x3 prime, which is equal to y triple prime. And then what we do is, once we reach x4, which is the number of derivatives that we have, we take a derivative of that, so we have x4 prime equal to y to the 4th prime. Okay? Do you guys see why we stopped here? Essentially, we stopped. So we only want 4 different variables equating to the 4th derivative. So then, my 4 equations is x1 prime equal to x2, x2 prime is equal to x3, x3 prime is equal to x4, x4 prime is equal to y to the 4th, which is this. So we solve this equation for x4 prime. So this is equal to cosine of t plus 3x to the 4th, because that's x3 prime, minus 2 x3, x3 is y double prime, minus 5 x2 minus x1, and then my x sub 1 of O, x sub 1 is equal to y, which is y sub O. So this is equal to 1, x2 of O is equal to 2, x3 of O is equal to 3, and x4 of O is equal to a 4. You need all of this information. I think on the answer solution, I have everything. So you need all of this. Okay? So now essentially you have 4 variables that are 4 first order linear equations. You can solve them using system of equations or something. Any questions on this problem? You guys good with this problem? Can I erase it now? Yeah? Oh, cool. So this problem normally isn't hard on the exam. But you do need to write out all 4 of those equations with the 4 initial conditions. Okay. So for this, they tell us to use the Laplace transform to solve these 2 equations. X prime plus 3x minus y is equal to 0. Y prime plus 2x is equal to 0. Did I give you guys the initial conditions for this? No? Yes? Okay. X sub O is equal to 1, Y sub O is equal to 0. Okay. -1. Thanks. So we use Laplace to solve it. Again, this sort of problem, once you've seen one of these problems done, it shouldn't be too hard. It's just not getting lost in the algebra. So doing the Laplace of the first equation, I have S times X sub S minus X sub O plus 3 X sub S minus Y of S equal to 0. So this is doing the Laplace equation. So in the Laplace of the second equation, I get S Y sub S minus Y of 0 plus 2 X sub S equal to 0. These equations, X sub 0 is a -1. So then if we categorize everything, I have S plus 3 times X sub S minus Y sub S equal to a -1. When we bring it becomes a +1 on this side, so it's a -1 in this equation. The bottom equation, I have 2 X sub S plus S. This goes to a 0. So it's just S times Y of S equal to a 0. So you can either eliminate the X or the Y of S. On this solution, they eliminate the X of S first, so we shall do that. But if I had this on the exam, I would have gone and eliminated the Y of S first. But it's good to see the harder version, eliminate X of S. So I multiply the entire quantity on this by a -2, the entire quantity on this equation by S plus 3, to get -2 times S plus 3 X of S plus 2 Y of S equal to a 2. Denominator, or sorry, the second equation, 2 S plus 3 X of S plus S times S plus 3 Y of S equal to 0. Any questions on this? Solving a system of equations. So now I'm left with my components of Y of S. So I have, if I multiply this out, I have S squared plus 3S plus 2 times Y of S equal to a 2. Then I solve for Y of S. That's equal to 2 over S squared plus 3S plus 2. This we can factor out to be S plus 2 times S plus 1. So then we do partial fraction decomposition. We get A over S plus 2 plus B over S plus 1. You guys should have done this stuff like 1,000 times. So since these would be easiest using the Heaviside method, for A, that's equal to limit as S approaches -2 to get rid of this S plus 2 portion throughout the equation. So then I have the limit of as s approaches -2 of 2 divided by s plus 1. If I plug in a -2 here, I get 2 over a -1. So I get -2 as my answer. For b, I have limit as s approaches a -1 to cancel out this portion. So then I have 2 over s plus 2. If I add a -1 here, I have 2 over 1. So b is equal to a 2. So that my y of s is equal to 2 over s plus 1. Sorry, yeah. So this is the b portion, 2 over s plus 1, a minus 2 over s plus 2. So this was the b portion, and this is the a portion. Any questions? So that's my y of s equation. If I want y of t, I have to do the inverse Laplace of this. So my y of t is equal to a 2 times the exponent e to what power? -t minus 2 e to the -2t. So now we have to solve for my x equation, but this is my y of t. This equation tells us that x is equal to 1/2 y prime. -1/2. Did I make a mistake? Let's see. Where does that come from? This equation, solving for x. Okay. Okay. My y prime is a derivative of this equation, which is -2 e to the minus t. Bring down the 2, so plus 4 e to the minus 2t. I multiply this equation by -1/2. My x of t is equal to e to the t, e to the -t, sorry, minus 2 e to the minus 2. That goes there. Yes. Wait, say the question again. Are you asking about this portion?
Yeah.
How I got this equation?
Yeah.
This was given to us. So this equation is y prime plus 2x equal to 0. So if I solve for x, I have 2x equals to -y prime. X is equal to -1/2 y prime. So then I find y prime, multiply by -1/2 to get my x of t. Any questions on this problem? Can I erase it? Okay. All right, let's move on to number 3. So we have to find the two ordinary differential equations from the partial equation, the double derivative of t, so d squared u over dt squared equal to 4 d squared u with respect to dx squared plus 2 times u. Okay. So I have to find the two ordinary equations with this equation, right? Okay. So we are given this. U is a component of x and t, and since it is a component of two variables, I have x of x, t of t. Okay. Each of those are independent equations, independent variables. So then, using this equation, this model that we made, I have to find each of these components, and then we know what u's are. So d squared partials of t squared. So the second derivative of u with respect to time is equal to x sub x times t double prime of t. Okay. Since they're independent equations, we treat this portion of the equation like a constant. Since we're doing the partial derivative with respect to time, so that each time it'd be first derivative and now second derivative. Okay. For d squared u with respect to partial of x squared, that will be, what will it be? Anyone want to say it?
X double prime of x times t of t.
Yep, so x double prime of x times t of t. So now we have those two. We plug those up here so that I have x t double prime equal to 4 times x double prime times t plus 2 times x times t. Do you guys see what happened here? Yeah? So now we solve for, we try to isolate the t's and isolate the x's. So we can bring we try to divide each portion. So this, we can say is x t double prime equal to, we can group t out, so I have 4x double prime plus 2x. So then I have t double prime over t on the left side equal to 4x double prime plus 2x divided by x on the right side. So now all the t's are on the one side, x's are on the other. Since they are independent equations, I can set this equal to a k. Their ratios will lead to a constant value. And using this, I can get my two equations. So if you just look at this part, I have t double prime equal to tk. So then t double prime minus tk equal to 0. That's my first equation. This equation, I have 4x double prime plus 2x. Now if I brought the k to the left side, minus kx equal to 0. And then if I group the x's together, I have 4x double prime plus quantity 2 minus x times k, 2 minus k times x equal to 0. That's my first equation. This is my second equation. So this is my solution. Yes?
So that first step is kind of independent from the actual problem. That's just the,
This step right here?
yeah.
Yeah, this is us like essentially making this up to get to equation. It's like we define u of t, u as a variable of x and t as like a model or something. 1 second. Okay. Any questions on this? And then if you were to solve it, you could solve it like Laplace or something, like system of equations and such. But normally, like they'll only ask you to find the two equations. Can I erase this? Yes? Make sure everyone signs in. There's sign-in sheets somewhere. Wait, where's the sign-in sheets? Has everyone signed in? Who hasn't signed in? Can you pass one down? Okay. Moving on to 4. This is with concentrations. So there's 3 or 4 different versions of these problems that they go through within the videos. Make sure you go through those 2 or 3 or 4 different versions, and then you'll know how to do all the problems. Okay. So make sure you practice the different versions. In this version, we don't have a constant volume, but in others, you have a constant volume. You might switch off the rates. The inlet and output rate might be different, or you might have a switch that changes the rate later on. So make sure you go through the videos on this. But for this version, we have a tank with an inlet flow of 4 meters cubed per second and a concentration of 0.5 kilograms per meters cubed. Coming out, we have the rate of 5 meters cubed per second. We have to find A of t. My initial A of 0 is equal to 10 kilograms. My initial volume is equal to 100 meters cubed. Okay. So essentially, a solution is flowing in and flowing out. But we have a change in volume in this, right? So the first thing that we do if we have a change in volume is we have to find V of t. How do we know that we have a change in volume? Yeah, because the input and the output rates are different. Okay. Since they're different, we need to find the equation for volume. If they're the same, you don't need to do that because you will have the constant value already. So dV over dt is equal to volume in minus volume out. I have the volume in as being 4 minus 5. So my rate or change in volume is -1 meters cubed per second. I take the integral of both sides to find V, so that V of t is equal to, a negative time plus c. And they tell us to find the time that the tank is empty. So then I have my initial condition, v of 0 is equal to 100, so that v of 0 is equal to a minus 0 plus 100. Minus 0 plus a c equal to 100, so that my c value is equal to 100. My v of t is equal to 100 minus a t. They ask us to find when the tank is empty. That means when the volume is empty. So that v of t is equal to 0. That's when we have 0 volume, equal to 100 minus a t. So that my time when the tank is empty is equal to 100 seconds. Did this make sense? I found my equation, negative t plus c, had an initial condition. At the beginning, the volume was 100, so that I found my c value to be 100. So my equation for the volume is equal to 100 minus t. When the tank is empty, that means the volume is equal to 0. I solve for time, and I get 100 seconds. Okay. Now, the reason they ask us for when the tank is empty is because more water or more solution is flowing out than coming in, so that the volume is decreasing. And that's what we see with the negative t. It's a downward slope equation. If I had greater volume coming in than going out, the tank would be rising, and this would be a positive t or some other function. Okay? Does that make sense? So just trying to understand what the system is actually doing with the equation. They also want us to find the equation of the concentration as a function of time. So I have to set up that equation, dA over dt. That is equal to rate in minus rate out. So I have rate in as 4 meters cubed per second. If I multiply that by the concentration of the solution coming in, 0.5 kilograms per meters cubed. My rate in is a function of kilograms per second, which is what we're looking for. So then minus the rate out, so I have 5 meters cubed per second. Now here's where you may have variability. We don't know the concentration going out. The concentration going out is a function of the concentration of the tank divided by the volume of the tank. Okay? So we're looking for this equation, A of t. So this is equal to 2, 4 times 0.5, minus 5a divided by my function for volume, which is 100 minus t. Any questions on this portion? So it's important to get this correct so that we can solve now for A. So this is equal to dA over dt. If we rework some of the, if we move things around, I have A prime minus plus 5 over 100 minus a t times A equal to 2. This is what sort of form? Or standard form? Okay. So that this is my P of t, this is my Q of t, in a sense. So we need to find mu now. Okay. Mu is equal to E times integral of P of dt. You guys all should be familiar with this equation. For this is my p-value, so this is equal to d to the integral of 5 over 100 minus a t times dt. Okay. So the integral of 5 over 100 minus a t dt, it's like du over u, so it's a natural log integral. I have a negative t here, so that means I need a negative numerator, because that's the derivative of the bottom. So the derivative of this is a negative 1. Okay. So this is my u value, this is my du value. So I have a negative 1 on the outside too. So this is equal to a negative 5 times natural log of 100 minus a t. So this right here is equal to e to the natural log of 100 minus a t. And then I bring the negative 5 up as an exponent, because we can do that with natural logs. The e and the natural log cancel out. So I'm left with my new value being 100 minus a t to the negative 5 power. Most of the process for these sort of problems is the same for everything. So if you do one problem, you should know how to do a similar problem. So make sure you go over the 3 different versions of this. Any questions on finding mu? I multiply mu with this equation so that I have 100 minus t to the negative 5 power times dA over dt plus 5 divided by 100 minus t to the 6th power, because I already have 100 minus t in the denominator, right here, times a equal to 2 times 100 minus t to the negative 5 power. Any questions on this? Okay. So all of this is sort of a review, but what do we do right here? Reverse product rule. So that's equal to the derivative of what? What 2 things? We take what's in front of here, so 100 minus t to the negative 5, and then we take the variable here, so a. So most of the time it is just as simple as this. You take the first part of this portion and the second part, the variable there. But you should always just double check that you did it correctly. So the derivative of a is d over dt. Derivative of 100 minus t to the negative 5th power is it'd be negative 5 over this, and then you have the derivative of negative t. So then the derivative is equal to 5 over 100 minus t to the 6th power. Any questions on this? So this is equal to 2 times 100 minus a t to the negative 5. We take the integrals of both sides, so that on the left I have an integral of a derivative. That shouldn't matter. So I have a times 100 minus t to the negative 5. On the right, I will have essentially a negative 2 times negative 1/4 times 100 minus t to the negative 4. Because the integral of 100 minus c to the negative 5 is 100 minus c negative 4 divided by a negative 4. But then I still have a negative t in here, so I multiply by a negative. So that is my integral plus c. Everyone good with this? Okay. So that my a of t is equal to, we divide by this factor, so I select a, negative 2 divided by a negative 4, I have a negative 2. Sorry, a positive 1/2. So I have 1/2 times 100 minus a t plus a c. Dividing c by negative exponent, it becomes positive, so c times 100 minus a t to the positive 5 power. So I had a negative 4 here, and I multiplied it by a positive 5 to get a positive 1 power for that portion. So that's my a of t, but they tell us our initial equation condition, a of 0 is equal to a 10. So if I have a 0 here, I have 100 divided by a 2 plus c times 100 to the 5th power. So that c, let's see, is equal to minus, we divided by. So if I isolate c, first of all, let me just do this. 10 minus 100 divided by 2. So this we could say is 20 minus 100 divided by 2 times 1 over 100 to the 5th power. This here is equal to negative 80 divided by 2, so t is equal to negative 40 divided by 100 to the 5th power. And we can leave it like that. So that a of t equal to 1/2 times 100 minus t minus 40 divided by 100 to the 5th power times the quantity of 100 minus t to the 5th. Does this make sense? Are you guys good with this problem? Yes? Can I erase it? Yep. In your videos, you had a problem where you had this until a certain time 10, right? And then the rate, so say this is 5, then the rate changed to a 4, something like this. No, the rate didn't change, the concentration changed. Right? You guys remember this problem? So the numbers are different, but in this there was a time step right here. When the first valve closed, second valve opened. Okay? So that involved a unit step function, right? I feel like that's the sort of problem they'll have on the exam. Okay. So make sure you definitely go through those. Okay, moving on to number 5. So we use Euler's approximation of y to the 1.5 with a step size of h equals 0.5. So they tell you the h value of the equation y prime equal to 2x plus y. This is my function. And the initial condition they tell us is y at 0 equals 2. That means x of n is equal to 0, y sub n is equal to 2. They tell us that x sub n plus 1 is equal to x sub n plus h. Y sub n plus 1 is equal to y sub n plus h times the function with x sub n times y, x sub n, y sub n. Okay. So they give you all this information. Essentially, the problem is a plug and chug, as long as you don't make algebra mistakes. Okay. So my x1 is equal to x initial plus h, which is 0.5, since this value here is a 0, this value here is a 0.5. X sub 2 is x sub 1 plus an h, so this is a 1.0. X sub 3 is x2 plus an h, so this is a 1.5. What we want, y at 1.5. Okay? This is where you, so when you have y, that's where the math really comes in. Y of 1 is equal to y sub o plus h times a function with x sub o comma y sub o. So my x sub o is 0, y sub o is a 2. This is equal to 2 plus 0.5. And my equation is 2x plus y. 2 times 0 is a 0. Y is a 2. So I have 2 plus 1. So this is equal to a 3. Does that make sense? My y2 is equal to y1 plus h times x1 y1. H times the function of x1 y1. My y1 we found out is a 3, so I have 3 plus 0.5 times 2 times x1. This is my x1 value, because that's the step that we took by h. So then I have 0.5 times a 2, so I have a 1, plus y sub 1, which we found is a 3. So this is equal to 3, plus 0.5 times 4, 3 plus 2. So this is equal to a 5. Okay. And then my y sub 3 looking for is equal to y2 plus h times the function x sub 2 comma y sub 2. is equal to y sub 2 is 5 plus 0.5 times the quantity x2. My x2 value is 1. 1 times 2 is a 2. So I have a 2 here, plus y sub 2, which is a 5. So that is equal to that. So this is 5 plus 7 times 0.5 is a 3.5. So this is equal to an 8.5. Okay. So that my y sub 3, which is a function of x sub 3, y of 1.5, is approximately 8.5. Any questions on this?
Why is the y equals 2x plus y less than y prime?
Why is this a y prime? So it's like you find a function. They made up a function with y prime and y, right? So you can't just find the value of y by plugging in numbers or something, since it's multiple variables like this. The function of y and x, you could do different values, right? But we don't know the values like y prime and stuff. Okay? So we use approximation with Euler's method to find the y at 1.5. Because we don't know what y prime of 1.5 would be. And then there's different methods, like the next one is Runge-Kutta method. Does that make sense? Like, you can, yeah, so this is a weird equation. We wanted to approximate what the value of y at 1.5 would be, and this is one method of doing it. So all the approximation methods are essentially plug and chug because they give you the equations. So just make sure you don't make algebra mistakes. So the next one, we use a fourth order Runge-Kutta method to find y of 1 with the same equation, y prime equal to 2x plus y. And they tell us that the step size is 1.0, so that h is equal to 1.0. Okay. They tell us that y of 0 is equal to a 2. This means my x sub o is equal to a 0, and my y sub o is equal to a 2. Okay. And then they give us all the equations, so essentially just working through them. My x sub 1 is equal to h times the function x sub n, y sub n. My h value is a 1. My x sub n is a 0, y sub n is a 2. If I have 2x plus y, x is a 0, so this is equal to a 2. So I have 1 plus 0 plus 2 equaling to a 2. Okay? So this is my k1 value. My k2 value is h times the function of x sub n plus h over 2, comma y sub n plus h plus k1 over 2. Okay. My x sub n value, again, is a 0. My h value is equal to a 1. 1 divided by a 2 is equal to 0.5. My y sub n value, we know, is a 2. K1 divided by a 2 is a 1. So my x portion is equal to 0.5. My y portion is equal to a 3. Okay. So if I plug in into the equation, I have 1 times 2x. 2 times 0.5 is a 1 plus 3. So my K2 value is equal to a 4. Did this make sense? Again, plugging and chugging essentially. K3 is equal to H times the function of x sub n plus H over 2, comma y sub n, this time K2 over 2. So my H is a 1. This doesn't really change since my x sub n and H are the same values. So I have 0.5 times 2, so that's the 1 again, plus my K2 value we found out is a 4. So 4 divided by 2 plus my y sub n, which was a 2. So 2 plus a 2. So I have a 4 right here for y. So this is equal to a 5. Okay? K4 is equal to h times the function with x sub n, this is where a change happens, plus h, comma y sub n plus k3. X sub n, again, is a 0. So this is 0 plus 1. My y sub n is a 2. So this is 2 plus a 5. So those are what go in the equation. So I have h, which is 1, times 1 times 2. So this is 1 times the quantity of 2, plus this is a 7 here. That's my y value, 2 plus 7. So that's my K4 is equal to a 9. My overall equation for y and n plus 1 is equal to yn plus 1/6 times the quantity K1 plus 2 times K2 plus 2 times K3 plus K4. So they give you this equation to find y to the n plus 1. So this is equal to y to the n, which is 2 plus 1 over 6 times K1, which is a 2. So it's 2 plus 2 times 4, so plus an 8, plus 2 times 5, so plus a 10, plus K4, which is a 9. Okay. If I bring my 2 to the 6th power, I have 12 over 6 plus, so this is 10 plus a 10 plus a 9, so 29. So 29 over 6. 12 plus 29 is 41. So my answer is 41 over 6, which is equal to y1, which is approximately y of 1. So our answer is 41 over 6. In the videos, they use both methods, the Euler's and Engr to approximate the value of B. And one of the things you realize is that the Engr method is better at approximating. It has its limitations, but we only needed to take one step instead of doing a lot of steps. Euler's, you need to do a lot more steps. Any questions on this problem? Again, it was, yeah.
So do you always go to K4, or do you have to go past that?
Yeah, we use, so what they're teaching you is the 4th order, which is K4.
Okay, and so it'll always be K4.
Yeah. Any questions? And they'll give you the equations again, so it's just plugging in the numbers. Can I erase this? Yeah. So that we can do the last one, and then So for the last one, we have to complete the Fourier sine series. Of f of x equal to a 3. So they're very nice. They just make it equal to a constant for this problem. Apparently. 0. So x is between 0 and 2. So that my L value is equal to a 2. That's the period we're interested in. And they tell us since what is sine? Is sine odd or even? Sine is odd. Someone said odd. Okay. And they tell you the equation, so which is really nice. So we need to find v sub n, which is 2 over L going from 0 to L. F of x sine of n pi x divided by L dx. So this stuff you guys already actually learned in previous calc classes. But yeah. And I actually use this stuff on co-op, so yeah, I actually did use this. Okay. So this is equal to 2 over 2 going from 0 to 2. My f of x is equal to a 3 times sine of n pi x over 2 dx. Okay. So this is equal to, if we take the integral of this, I have to multiply the outside by 2 over n pi x, and inside by n pi x over 2. Not x, 2 over n pi, and then n pi over 2. And what is the integral of sine? Negative cosine. So that this is equal to a negative 3 times 2 over n pi times cosine of n pi x over 2 going from 0 to 2. Okay. This is equal to a negative 6 divided by n pi times the quantity. So if I plug in a 2 here, the 2's cancel out. Well, I'm plugging in more than. So I have cosine of n pi. Okay. Cosine of n pi is either two values, essentially. It's 1 or negative 1. Okay. So I have negative 1 to the nth power, because it changes depending on your n value. And then I have cosine of 0, which is a 1. Okay. So depending on my n values, though, I could have, if I have n equal to 1 or an odd number, I have a negative 1 minus a 1. That's a negative 2. Negative 2 times the 6 is a positive 12 over n pi. So these are my odd n values when n is odd. When n is equal to an even number, like a 2, I have 1 minus a 1, so that my end result is a 0 when n is equal to an even. So that my f of x, so this is equal to b sub n. F of x, I tell you, is equal to the summation k equal to 1 going to infinity of v sub k sine of k pi x over L And this include the restrictions in your final answer, so we'll need to remember. So it's a summation. So we found for when k is equal to an odd number, going to infinity, v sub n is 12 over n pi sine of k pi x over 2. But we want for all k values, so we make this k, we'll call it capital K, equal to 2 del k minus 1. If we make that substitution, we have it f of x for all k values. So when I have k equal to 1 going to infinity, I will have 12 divided by, this should be a k right here, 2k minus 1 quantity times pi. And then I have sine of 2k minus 1 times pi x divided by 2. But don't forget the k inside the sign. And then my restrictions, which they say to include in my final answer, x is between 0 and 2. So for these problems, you either have to deal with what we did right here, or you might have a lot more to deal with when you have cosine or sine or so they asked us for Fourier sine series. You might be asked for Fourier cosine series. So for this, okay, for Fourier cosine series, you have a sub naught and a sub n, right? You have to find those two, and they'll give you the equations. So just go over the different problems that are possible, and that's the best way to be ready for it. Any questions on this? No? Okay, thanks for coming, guys.